Welcome to EDU World Space.
Problem 3.125. In this problem, we have to calculate three things. First, the forces exerted at B and C, that is, we have to find the unknowns B, Cx, Cy and Cz. And in second part, we have to calculate the value Ry and Rz. And in third part, we have to find the best orientation in which the slot should be put so that it resists the maximum resistance, that is it is least likely to slip. All right, so first of all, what we are going to do, that we will equate these force this resultant force that is given in the problem to the actual forces acting on the system, that is by equating the forces. So this R resultant is given as minus 25 Newton I cap plus Ry j cap plus Rz k cap. And what are the actual forces acting? So in x direction, only one force is there, Cx I cap. In y direction, again only one force is there, Cy j cap. But in z direction, there are two forces, so it will be Cz minus B k cap. Now equating the coefficients or comparing the coefficients, Cx comes out to be minus 25 Newton. So this, let's say this is our first equation that we have got the value of Cx. Now we can calculate moment about point A, and since the net moment is already given in this problem to be minus 13.5 Newton meter I cap, so we can calculate these moments about A and compare again the coefficient of the moments. So for the moment about point A, so we can write it to be as position vector of point B with respect to point A cross multiplied with the force at B, that is minus B k cap. And for the second set of forces that is at point C, so position vector of point C multiplied with forces acting there, that is Cx I cap plus Cy j cap plus Cz k cap. And all these forces should be equals to, should give the value to be minus 13.5 Newton meter I cap. Now putting the values of R vector in the problem in this equation, so RB with respect to A is, so we can see here that this distance is 240 mm. So along the x-axis, the point B is at a distance 240 mm, and along the y-axis it is at 180 mm. So we can convert it in meter and we can write it to be 0.24 I cap plus 0.18 j cap multiplied with minus B k cap plus position vector of C. Since point C is on x-axis, so there will be only non-zero coefficient of I cap, and it will be 0.48 meter, since that is 480 mm. So 0.48 meter I cap multiplied with the forces acting there, that is Cx I cap plus Cy j cap plus Cz k cap. And all these forces again should be equal to minus 13.5 I cap. So we can solve this cross product by using determinant method. Here is I cap, j cap, k cap. So this coefficient of position vector is 0.24, 0.18, 0, and here 0, 0, minus k. Now we can do the same for the second set. This is I cap and this is going to be j cap, this is k cap. So I cap here is Cx, Cy, CZ. Oh, sorry. So here 0.48 is in I cap, 0, 0. This is CX, CY, CZ, and it should be equal to minus 13.5 I cap. Now expanding this determinant along first along X, then along Y, and then along Z, we can get the values. Right, so correcting the coefficient of I cap in first determinant, it will be minus 0.18. Okay, so here it is B, minus 0.18 multiplied by B, and only this will be there for the coefficient of J cap. Since in determinant this will be plus, this is minus, this is plus, so here the sign of J will be negative, so minus J cap multiplied by 0.24 into minus B, and no other term will be there. For K cap, its coefficient is going to be 0, since if we see this determinant, this will multiply, both the term is going to multiply with 0. Now in second determinant, again doing the same thing, the coefficient of I cap will be 0. The coefficient of J cap will be, again I'm doing the same mistake here, sorry, this will be minus J cap, and the coefficient will be 0.48 CZ, and no other term will be there. For the coefficient of K cap, so it will be plus K cap, and the only term it involved is 0.48 CY, and this will be equal to minus 13.5 I cap. Now in left hand side, collecting the coefficient of I cap, this comes out to be, here the only term is 0.18 minus 0.18 B for I cap. For J cap, there are two terms. Here the first term is 0.24 B, and the second term here is minus 0.48 CZ. For the coefficient of K cap, there is only one term, that is 0.48 CY, and all these terms should be equal to minus 13.5 I cap. Now comparing the coefficients of I cap, I cap, J cap and K cap, comparing the coefficients, it is going to give minus 0.18 B will be equal to minus 13.5, and by solving this, minus 13.5 divided by 0.18 is going to give the value of B to be 75 Newton. So we got the second value. Now comparing the coefficient of J cap, so we can write it as 0.24 B minus 0.48 CZ should be equals to 0, since there is no term involved in the right hand side. So from here we can calculate the value of CZ, and CZ comes out to be, since B is already known, so CZ comes out to be 37.5 Newton. Now we got the another value, another unknown. Now comparing the coefficient of K cap, 0.48 CY will be equals to 0, so CY comes out to be 0. So now all the forces at point B and at point C are known, since we got the value of B to be 75, Cx we have already calculated, minus 25. Here we got Cy to be 0 and Cz to be 37.5. Now again coming to the the very first equation that we have written initially, that balancing the forces of the resultant forces acting on the system that is given in the problem and comparing them to the actual forces that are acting on the system. So again we are doing the same thing, so we can get the value of Rx, Ry and Rz. So this equation will involve minus 25 I cap plus Ry j cap plus Rz k cap, and equating it to minus b k cap plus cx I cap plus cy j cap plus cz k cap. So it can also be written as minus 25 I cap plus Ry j cap plus Rz k cap and minus 75 k cap plus cy is already 0, so this term is going to vanish, and the cy, sorry, I did a mistake. So this term is going to be 0, cy is 0. So cx is minus 25 I cap plus cz is 37.5 k cap. Now comparing the coefficient of I cap, since already they are same, coefficient of j cap, again we are going to compare the coefficients. So Ry comes out to be 0 since there is no term involved in the right hand side for the j cap, and Rz comes out to be minus 37.5 Newton. So we have got the value of Ry and Rz that was the asked in first part of the problem. Now coming to the second part. In second part they had they had asked, let's see, they were asking the value of Ry and Rz. So we had already got that value. So in third part they are asking about the best orientation for the slot such that they are least likely to slip. So what we will do, that we will write the total reaction force exerted by the head of the system. So R is minus 25 I cap, since Ry is 0, only Rz component is there, 35.5 Newton. If we observe this reaction force, so we note that in Z component there are minus 35, they resist 35.5 Newton force, while the X direction is going to resist only 25 Newton force. So in Z direction they resist more forces. So we can say that when the slot in the head of the screw is vertical, it is going to be the best possible orientation or the best orientation, so that there will be least slip